Alright, now we have this video, and this video is also I will going to talk about limits at infinity and horizontal asymptote, but this is a special case here. So before we talk about what type of special case, what type of limits that consider as special case, so I have to introduce you these techniques here. So okay, you have to understand this. As you know that modulus of x is defined to be square root of x squared, right? Modulus of x is defined to be square root of x squared, right? So we can rewrite as this one. So, and at the same time, modulus of x is also x and negative x when at square root of when x is greater or equal 0. When x less than 0 means when x is negative, the modulus of x can rewrite as negative of x, so that it becomes positive, right? So when x is a positive number, so you can rewrite modulus x as x here. Alright, so, and you know that square root of x squared is actually modulus of x, right? So I can rewrite this thing. So the important thing here will be, this one can rewrite, I can rewrite this as modulus of x is the same as square root of x squared, which is also the same. It will be x when x will be a positive value. So it's negative x when x has a negative value here. Less than 0 means negative value here. Means that you can convert, once you see that x is a positive value, you can convert x to be square root of x squared. Square root of x squared. So if you see that x to be negative, so you can consider square root of x squared to be negative x here. So it means that when x greater or equal 0, right? When x greater or equal 0, square root of x squared will be x, right? So when x is less than 0, the square root of x squared is negative x, right? Negative x. Or I can say that x is negative square root of x squared, right? I can divide both sides by negative here. So, alright. So then there's come a conclusion here where I want to use this technique here. So now, of course, you don't know what is happening, but I have to explain to you. This one is the same as square root of x squared, and the modulus of x is x and negative x. You know this definition, right? So you have more positive, you have x, negative, you have negative x. So, and this one can be rewrite as square root of x squared, right? Square root of x squared. And when x is positive, square root of x squared. When x is positive, square root of x is x. When x is negative, square root of x squared will be negative x. Square root of x squared will be negative x. So it means that x will be negative of square root of x squared, right? Or I can say, alright, this one, so negative square root of x squared. So this will be a very important result here. So now this is a special case here. Please jot down this thing, okay? Because I'm going to discuss what is meant by special case to evaluate a limits at infinity where involving special case. So okay, let's look at the examples. Alright, so the special case here, this will be a special case. So why special case? Because we use different techniques for these cases. So you look at, because there is only one square root, there is a surd. Okay, either the surd is on the denominator or on the numerator. One is the surd and one is the polynomial function. Alright, for this type of cases, one of the function is a surd, then we consider to using these techniques where when x is positive, so we're using we assume that the x to be square root of x squared, right? X to be square root of x squared. Okay, you don't this one is the methods that I'm going to tell you. So previously I have explained about the concept of getting this, right? Why this one you have to choose x to be square root of x squared? Why? Because it's the concept of modulus. So when x less than 0, you will choose x to be negative square root of x squared here. So why is it this one is positive of square root? Why is it negative? I have explained in the during the concepts when I introduced the techniques for this one, right? So you actually see the derivation why I'm doing this. So now, okay, very simple. Okay, now you just see the techniques. When positive, you choosing x to be square root of x squared. When negative, x less than negative, you're choosing x to be negative square root of x squared. So now you look at here. This one will decide. This is the case where when you're putting infinity, square root of infinity square, you're getting infinity. So when you put infinity here, 4 times infinity, you are still getting infinity. Right? So case infinity, but this is a special case because without the square root, this is a normal one. You divide by x, right? Or everything by square root, you divide by x. But now it's one of the function here is square root. So very easy. The techniques here will be, if you have one of the function is square root, you divide up and down by x. Okay, divide up and down by x. This one also you divide by x over x, the technique here. So divide by x. So for this one should be okay. You can getting limits. We talk limits as x approaching positive infinity. So you will divide by x. So 4x over x, you were getting 4. Right? 4 minus 1 over x. 1 over x. But for this one, you cannot divide because there is a square root. You cannot divide x squared with x because there is a square root. That's why we need this knowledge here. So this one shows what? X is positive. X is positive. Why? Positive infinity, right? Positive infinity is a positive x value. So it's in this region. So you were choosing the x to be, you will replace the x here because you need the help from this one. So you replace the x with square root of x squared. X with square root of x squared here. So square root of x squared plus 1. I convert the x here to become square root of x squared. Can you see that? I change become square root of x squared. So that you see, you were changing the limit as x approaching positive infinity. So of course the square root, this one also have square root. Then you can later combine them together, right? So you have square root, both you have square root. So you have x squared plus 1 over x squared. 4 minus 1 over x, right? And later you can evaluate easily limit as x approaching positive infinity. 4 minus 1 over x. Then square root x squared over x squared, you have 1 plus 1 over x to the power of 2, right? Without this concept, you cannot divide the x squared with x, right? So after I convert x become a square root of x squared, you can bring the x squared into the square root. So now you can evaluate the limits here. So positive infinity, so you're getting 0, right? 1 over x squared infinity getting 0, so also getting near to 0. So finally you have square root of 1 over with 4, which give you 1 over 4 as your answer here. So I will do more example for this type of cases so that you understand better. Okay, let's move on. What happened when this is a negative number, negative infinity? Alright, now for the same limits, the same function but x approaching negative infinity. Alright, I'm going to explain again how to deal with this type of problem here. So the easiest way will be first, you see this is a negative number, positive infinity. If this is a negative infinity, the choice will be different. So x approaching negative infinity, as you divide up and down by x, or you divide up and down by x, so square of x squared plus 1 divided by x. And here you also have 4x minus 1 divided by x here. Yeah, so later, okay, this is the part where it's very important because there's negative infinity here. So for this x is okay, right? It's okay because why? You can divide 4x by x. You're getting 4 minus 1 over x. But for this case here, there is a square root. You cannot take x squared divided by x because they don't have the same power, right? You cannot divide. So how? I'm going to modify this one based on this region here. This is a negative, right? It's a x less than 0, negative infinity. So you were choosing the x to replace with negative square root of x squared. So it means that I'm going to square root of x squared plus 1. For this x here, I'm going to replace with negative square root of x squared. I was choosing that because x approaching negative infinity is something negative, right? I'm choosing that. So what happened when this is positive infinity, right? From the previous, it's positive infinity. Positive. So I was choosing the x to be without the negative square root of x squared. So very easy, right? To understand. So limit when x approaching negative infinity. So over 4 minus 1 over x. For this one, you have square root. You can rewrite, okay, let's say you have square root of a, square root of b. You can rewrite as square root of a over b, right? Very simple concept here. So it means that, but there is a negative here, right? Negative, the negative is outside the square root. Outside the square root means that x squared plus 1 over x squared. So now you have know that limits as x approaching negative infinity. Inside the square root, now you can divide x squared over x squared. You're getting 1 plus 1 over x to the power of 2 divided by 4 minus 1 over x. Now you have simplified to this form because why? You want to decide the value here. As x approaching negative infinity, this whole thing will approaching 0. This also will be approaching 0. So, but you are getting negative square root of 1 over 4, which gives you negative 1 over 4. Right? So you are getting negative when it's negative infinity. But from the previous example, if you have positive infinity for this function, okay, do you still remember what's the value? The value when it's positive infinity, when you're solving, you're getting 1 over 4, right? You're getting 1 over 4, and this one you're getting negative 1 over 4. So it means that, so when you find the limits at infinity, the value here is represent the horizontal asymptote. The y value, right? The y value, the horizontal asymptote. Means in this case, this special case here, this function has 2 horizontal asymptotes. So it means that therefore, y equals to negative 1 over 4 and y equals to 1 over 4 are the horizontal asymptotes of this function here, fx. The fx here refer to this one, okay? This one, this is will be the horizontal asymptotes here. So I will do one more video for you about this type of concept here. If you're not very understand about this one, I will do one more video for you, but I'm using the same techniques here, the special case here. So try to look back this video. So play back and you look at why you're getting this, right? So if you want to solve, you just use this one. Okay? Just use this concept here.